So today we're talking about standard 2C, which is the segment and angle addition postulates. So what it says is that basically if B is between A and C and ABC are collinear, then AB plus BC equals AC. So the two segments have to add up to be the whole thing. As a side note, a postulate is a statement that is accepted as true without proof. So a segment addition postulate is accepted as true without proof. All right, so let's look at two examples here. We're going to write the segment addition postulate for the points described. Draw a picture to help. So number one, S is between D and P. So we've got D here, P here. Connect them, and then S is somewhere in between. Not necessarily directly in the middle, but just somewhere in between. So the segment addition postulate would say that DS plus SP has to equal DP. And so there's our segment addition postulate. All right, number two, J is between S and H. So same thing. We're going to draw a segment. So here's S, here's H, and J is between. And then segment addition postulate says that SJ plus JH has to equal SH. All right, now one with some actual numbers. So we've got DO is 4x minus 3, OG is 2x plus 21, and DG is 60. So we've got blue segment and red segment have to add together to be the whole green segment, which is the 60 feet. So I'm going to set up 4x minus 3 plus 2x plus 21 equals 60. And then we're going to combine like terms and isolate x. So we get 4x plus 2x is 6x. The negative 3 and the 21 are 18 equals 60. Go ahead and subtract my 18 from both sides. So I have 6x equals 42. Divide both sides by 6. And x is 7. So now we've got our x value. Have to substitute it back in to find DO and to find OG. So we get 4 times 7 minus 3, and that's 25. And then 2 times 7 plus 21, and that's 35. All right, next example. So I will preface this with that when we did this with the other class, we realized that these numbers turn out kind of funky. But we're going to work through it anyway so you can see it set up and do the factoring with the quadratic. So AB is 4x squared, BC is negative 23x, and then the whole segment AC is 36 plus x squared. So now we're going to say the two parts have to add up to the whole, so 4x squared plus our negative 23x has to equal 36 plus x squared. And this is a quadratic, so I want to bring everything to one side so it equals 0 so that I can factor. So I'm going to subtract the x squared and then also subtract 36. And I get 3x squared minus 23x minus 36 equals 0. Now, guess and check on this one would be kind of tricky because there's so many factors of 36 to guess with. So I'm going to do it the other way, the factor by grouping. So 3 times negative 36 is negative 108. And then I want factors of negative 108 that add to be negative 23. And that's negative 27 and 4. I'm going to use those two values to rewrite my middle term. So we get 3x squared minus 27x plus 4x minus 36 equals 0. And then I group my first two terms, I group my second two terms. From the first two terms, I can factor a 3x. And from the second two terms, I can factor a 4. And so that means my two factors are 3x plus 4 and x minus 9. All right, so now zero product property says 3x plus 4 equals 0 and x minus 9 equals 0. And I do a little mental math, subtract the 4, divide by 3, we get negative 4/3. And on the right, we add the 9 and get negative 9. So now I want you to notice something here. If x equals negative 9, and I were to sub it back in to BC, negative 23 times positive 9 would give me a negative segment length. So what that means is that x equals 9 can't actually be one of my solutions. It's called an extraneous solution. So it makes BC a negative measurement, and we can't have that. So therefore, x equals negative 4/3 is the x value that I'm going to use to substitute back in to find the measures of my segments. So we're going to go, to find AB, we're going to do 4 times negative 4/3 squared. And negative 4/3 squared is positive 16/9. And then 4 times 16/9. Let me make this a little smaller real quick. All right, so 4 times 16/9 is 64/9. And so that's my AB. For BC, I'm going to substitute into negative 23 times x. So negative 23 times negative 4/3. And that will give me positive 92/3. And then for AC, there's two ways to find AC. I can just add AB and BC. And if I just do that in my calculator real quick to get a common denominator, we get 340/9. So I got that by just adding 64/9 with the 92/3. Now the other way I could do this is I could take the negative 4/3 and I could substitute it into 3 plus x squared. So 36 plus x squared. So 36 plus negative 4/3 squared is also 340/9. So either way you do it, you get the same thing. Okay. So now moving on. All right, moving on, angle addition postulate. So this says B is in the interior of angle MLK if and only if measure of angle MLB plus measure of angle BLK equals measure of angle MLK. So in other words, this pink angle plus this green angle, those are the two small angles, they have to add up to this blue angle, which is the whole angle. So it's the same as with segments, just with angles. The two parts have to add up to be the whole. So let's look at some examples. So first example says, find measure of IJA. So IJA I'm calling x. Measure of angle AJK is 61. And measure of angle IJK is 153. That's the whole angle. So I'm going to set up an equation. 61 plus x has to equal 153. If we subtract 61 from both sides, I end up getting x equals 92. And so that's my x value, and actually I should write that that's measure of angle IJA, which is what the question is asking for. So measure of angle IJA equals 92 degrees. All right, next one. So here, angle TMN is x plus 72. LMN, which is the whole angle, is 166. And LMT is 96 plus x. So set up my equation. The two parts have to add to be the whole. So 96 plus x plus 72 has to equal 166. All right, now we add our like terms. So x plus x, that's going to give me 2x. And 96 plus 72 is 168. Subtract 168 from both sides. And we get 2x equals negative 2. Divide by that 2, and x is negative 1. Now what this is actually asking for is measure angle LMT. So I have to take my negative 1, plug it back in for x. So measure angle LMT equals 96 plus the negative 1, which is 95. Done. Okay, last one. Given the following information, where D lies on the interior of angle ABC, find all of this stuff. So this is another kind of funky problem, but we're going to work it out. So here's my angle A, B, C, and D lies on the interior. So angle ABD is x squared. DBC is 2x squared plus 4x. And then measure angle ABC is negative 2x. So now I'm going to add my two parts, set them equal to the whole, so x squared plus 2x squared plus 4x equals negative 2x. We've got a quadratic, so I want to make sure everything's on one side of the equal sign. So I'm going to add 2x. I get 3x squared plus 6x equals 0. And I'm going to factor. Now, this isn't a factoring like normal. This isn't a trinomial. This is a binomial. So you had some of these on that big factoring packet we did the other day. But what you want to do is just look and see that both terms are divisible by 3 and by x. So you can factor 3x out. And you're left with x plus 2. And so now you have 3x times x plus 2 equals 0. So either 3x has to equal 0, or x plus 2 has to equal 0. So we say 3x equals 0, x plus 2 equals 0. We divide by 3, and we get x equals 0. And on the other one, we subtract 2, and we get x equals negative 2. Okay, now, let's see what happens with each of these x values. So let's start with x equals 0. So if x equals 0, I want to find angle ABD. I'm going to substitute it in, and we get 0 squared, which is 0. Then we find DBC, so I get 2 times 0 squared plus 4 times 0, which is also 0. And angle ABC is negative 2 times 0, which is also 0. So this is where this problem is a little weird, where all the angles end up equaling 0. Now let's try that x equals negative 2. So if x equals negative 2, we've got negative 2 squared, which is positive 4. For angle DBC, we'd have 2 times negative 2 squared plus 4 times negative 2, which is 2 times 4, so we get 8. And then 4 times negative 2 is negative 8, so we end up getting 0 there. And for ABC, we'd have negative 2 times negative 2, which is positive 4. So again, another kind of weird one where we get 0 for one of the angle measures. So I would just make sure that on a test or a quiz that the numbers weren't so funky. But the math and the way we set it up is